share, and then now it's
there.
there.
We go. Now.
So there, I'm going to start as if we're talking about the unit circle. There's 30 degrees, and here's 220. Here's 325. 325 is kind of like here. That's 325 degrees. So how many degrees did she turn to make this change? Well, it's the difference between the two, because she's already at 30 and she's going to 325. So it's 325 minus 30, which is 295 degrees. Now, how do we convert that to radians? We have degrees and we have radians over here. How do you convert between the two? Do you remember?
Don't you like multiply by 2 pi? Or pi
over 180. And if you want to go this direction, you multiply by 180 over pi.
Okay.
So this 295, we can multiply by pi over 180. Are you allowed to use a calculator on this test?
She has not said.
Okay.
Most times she lets us do it for like certain problems on the homework, but not all of them.
Okay, so this is one that you generally have to reduce by hand. You have to simplify this fraction. So usually 5 is a good number to try here. So there's 5 20s and 100. Okay, so you can reduce this down. This ends up being there's 20. This is almost like 300, so that would be 60. So that becomes 59. 180 is divided by that is let's see, there's 28, there's 25s and 100, and then there's 16, so it's 59 over 36 pi for that. So this one we're emphasizing the
so what did you divide by in both of them?
By 5.
Oh, okay.
Yeah, that's why I asked, because it's kind of a tough skill if you're not familiar with it. Okay, so this is an overlap question, but I think it's worth doing. I'd like to also go ahead.
So the degrees that she went is
295.
295, and then
I just added in this little wrinkle of converting it to radians.
Okay.
Okay, so I want to go through this problem with you because it emphasizes something pretty important, which is this arc length formula.
Mm-hmm.
So the arc length, if you imagine a circle and you cut out a little piece of it, the pizza slice, if you will, there's an angle here, there's a radius here, and there's S here, and S equals r theta. Okay, but theta is in radians. Okay, so like if this said 45 degrees, this formula doesn't work because it has to be in radians, not this.
Okay.
Mm-hmm. So the radius here is given. It's 3956 miles, and they said a nautical mile is 1 minute. So they're they're saying like this. I think they're saying that this is 1 minute here. I guess. Okay. I'm not entirely sure actually what this problem is asking for, but nautical mile is 1 minute of arc, because one minute is if you recall degrees, there's minutes, and then there's seconds.
Right.
Okay, so I believe it's referring to this part. 1 minute. There is 1 degree is equal to 60 minutes. So 1 minute is a 60th of a degree. So 1 minute times there are 60 minutes in 1 degree. 1 over 60. That's degrees. Okay. But I just said this formula is not in degrees, it's in radians. So how do you convert this to radians?
Multiply by pi over 180.
Pi over 180, yeah. Okay, so there's your formula. S equals r theta. R is 3,956. Theta is this 1 over 60 times pi over 180.
Okay, so then you So you do the stuff inside the parentheses first.
This is a calculator. Like you would definitely need a
Okay.
calculator. To this you couldn't do this without that.
Calculator. So it's 3,956 times number species times pi over 180. So it's 1 point. Wait, do I put it in radian mode? Or do I put it in degrees?
No, radian mode is when you're taking the sine, cosine, or tangent. That's when you care about that.
Okay, I got 1.15.
Yes.
Okay.
Yes. Okay. Let me just briefly go through question 6. Because I think this is important. It's a conceptual problem. I think you said you get some of those on your exams.
Yeah.
So you have a wheel, and you've got it's rotating, right? It's rotating at 2 radians per second. Great. And there's 2 places on this wheel that we care about. There's the middle of one of the spokes. So we're going to call that little r here. So there's a spoke that's traveling a little r, and there's big R kind of out on the rim. Okay. Now, but before we answer these questions, I want you to think about, there's someone here, and you are running, or maybe your friend, I don't know, you're running at a circle like this around that person. If someone else is out here, do they have to run faster or slower to keep up with you?
Faster.
Faster, because there's more distance to cover.
Right.
Okay, so they don't tell you this, but angular speed W is velocity times radius. Okay, and the W is what they're actually asking you about here. What's different about R and big R besides the size of the letter? So big R might be like 1, but little r might be 1, but big R is 2. So if V is the same in both, which is going to have the higher W?
2.
W2. So the speck of dirt that is further from the center is a higher angular speed.
Okay. Okay.
All right. And then V is equal to W over R. I don't even know if this is covered in your class, but V1 is W over little r, V2 is W over big R. So if W is the same in both, okay, we're making a different assumption here. If W is the same, this is the kind of thing you do in physics. If big R is larger than little r, how does that affect V1 and V2? And again, think of numbers like dividing by 1 versus dividing by 2.
Well, you would have a bigger number in the V2.
Well, one you're dividing by 1 and one you're dividing by 2, but they're the same. Like W is the same. So think of it as like, sometimes you got to put numbers in, like 10 divided by 1 versus 10 divided by 2.
Oh, so it would be bigger in V1.
It would be bigger. So conceptually, it's like here the angular speed is higher, but here the linear speed is higher.
Okay, so the difference between little r and big R is just a number. It's not like any they're both angular speed.
Yeah. So you're W is angular speed. What we're trying to do here is something that's very conceptual, and it's very hard to do. It's like what I'm trying to do is keep it simple. The numbers are what help you to make the decision. It's like if V is the same but R goes from 1 to 2, what happens to W? Well, it goes up by 2.
Mm-hmm.
And then over here, we're trying to do the same thing. If r goes from 1 to 2, well, what happens? Well, v1 is bigger because v2 is divided by 2. So you use the numbers to help you make these decisions. And it's very hard to do because you're used to just having numbers, but these are like conceptual exercises.
Okay, so you would just say like the second bicycle wheel has a higher angular speed, right?
Well, it's the same wheel, it's just like different places on the wheel.
Oh, so the one farther away. Okay.
Yeah, the one further away has the higher angular speed.
Because there's more difference to cover.
But if they have the same angular speed, then then you have a higher linear speed there in the middle.
Okay. All right.
Okay, so let's look at this. I'm gonna answer a bunch of things here. Explain in terms of triangles why sine 45 equals cosine 45. So there is a special triangle that you need to know called a 45-45-90 triangle. And the reference is that you have x, and x root 2 for that. So if we put some numbers in, and this is exactly what I was mentioning in the previous problem, you have to sometimes put some numbers in. Let's say this is 6, 6, and 6 root 2. Okay, and I'm going to call this A. What is the sine of A? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. The sine of A is
6 over 6 root 2.
Great. And that becomes 1 over square root of 2. You should know by now to rationalize that. So that becomes square root of 2 over 2. What was A as an angle measure in our problem?
45.
45. So we say, okay, the sine of 45 is square root 2 over 2. Cosine A is what? 6 over 6 root 2. So it becomes the same thing.
Okay.
So we can say that the sine of 45 equals square root of 2 over 2, and the cosine of 45 equals square root of 2 over 2. What is the tangent of A? What is the opposite? What is the opposite over the adjacent?
6, so 1.
6 over 6, which equals 1. Okay. All right. Now, let's do, see, sine, okay. So let's do something different here because I think this is a critical skill. There are special triangles that you need to know to be fast, not just here, but for your SAT, ACT. So I'm listing a couple of these. There are an infinite many of these. And what this refers to is if I give you a triangle and tell you that this is A, this is B, and this is C, A, comma, B, comma, C.
Okay.
So like for example, let's say I gave you a problem. I said, all right, here's a triangle. This is 5, this is 13, and this is B. You are supposed to immediately realize that this is 5, 12, 13. That B is 12. But here's why. It's 5 squared plus B squared equals 13 squared. 25 plus B squared equals 169. B squared equals 144. So B equals 12. All right. So this is just a brief kind of aside here. I'll also point out that you can do multiples of these. Like you could take this thing and multiply it by, say, 10. So 30, 40, 50. You could divide by 10 if you wanted any of these. So 0 0.8, 1.5, 1.7. You can do anything you want. Multiply, divide, whatever you want here.
Okay.
Now, back to what you care about. Let's say that this is angle B here, and this is 5 now. We want to find the 6 trigonometric functions at B. Sorry, let me get to where this is showing up better. So sine B, cosine B. What is sine B?
Opposite over hypotenuse, so 5 over 13.
5 over 13. What's cosine B?
Also 5 over 13.
Oops, I'm sorry. No. This is 12.
It's 12
Whoops.
over 13.
Yeah, thank you. Okay, how about cosine B?
5 over 13.
Great. Okay, now from here, there's some important relationships, like cosecant of B is the reciprocal of sine. It's 1 over sine B. I usually just get this one, then take the reciprocal of it.
Isn't cosine B the same as, as 5 over 13? Isn't there like overlap between cosine and what is that? CSC? What is that?
Sine and cosecant are reciprocals.
Isn't there one that's like the
Cosine and secant are reciprocals.
oh, okay.
So you could write 1 over 12 over 13, but that's silly because you can just flip it and write 13 over 12.
Oh yeah, they're just the flip of each other. Okay.
Yep. And then secant B, you could write as 1 over 5 over 13, but that's silly, right? 13 over 5.
That's what I was trying to say. But
Now tangent is opposite over adjacent. It's also sine over cosine.
okay.
So you could write 12 over 13 over 5 over 13. Because the bottoms are the same, it becomes 12 over
Wait, why
5.
can't you just do tangent as SOHCAHTOA off?
You can. There's lots of ways to do this. There's, it's like if you open up a Word document, you can cut something by using the keyboard, right clicking, going up to menus. Like you have to decide what you like here.
Okay. What about cotangent? Is that just 5 over 12?
Yes, cotangent is the reciprocal. It's 1 over tangent, which is yeah, 5 over 12, exactly. Okay, is your goal to get through all of this? Because if it is, we have to move to 4.3 now. If it's not, we can.
No, whatever you think is best.
Well, I wish I knew what your tests look like to know what to tell you here, because I'm not really sure.
Let's move to 4.3. I could probably take
Okay.
2.
All right, so this is the point where I'm going to send you a link to the to a really good reference sheet that I like. I wish I had my own, but this one's really good because it's got everything you need for this class. Like there's nothing missing, and we're going to focus on page 3, which has got the unit circle on it.
Okay.
But you'll like what else is there. It's pretty comprehensive. So page 3 has this really wonderful unit circle. Maybe you've seen that in class, I'm hoping. And one of the things that's really powerful about the unit circle, I'm going to snip in just the first quadrant, is that you can do everything. You can do everything from the first quadrant if you know some other stuff. So this is really all you need to memorize. I think we were having this conversation recently about how much to know. You can really get away with doing all of everything here in this particular one. So there are this 4.3 focuses on the positive and negative of each trigonometric function in each quadrant. All right. So there's this. I don't know what, I think it's a mnemonic. I don't really know what exactly it's referred to, but it's written like this: ASTC, and it's remembered as all students take calculus. That's not true, but that it is true for this right here, and we have to know, like, well, what does that mean? Okay, the A means all positive. What is it referring to? Well, it's actually just referring to sine and cosine being positive. If you recall over here, x is the cosine, y is the sine. Do you see how all these values are positive?
Yeah.
Yeah. Now, what is tangent again? It's sine over cosine.
Yeah.
It is also positive here. So all actually refers to all three of these.
Okay.
And we'll talk about cosecant, secant, and cotangent in a moment. This right here refers to sine being positive. So if you've got your unit circle up on that page 3, you'll see that the y values are positive in all those ordered pairs. Do you see that?
Yeah.
Okay. The cosine is negative. You'll notice all the x values are negative there.
Uh-huh.
Since tangent is sine over cosine, positive over a negative, tangent is negative in that quadrant. So the letter here tells you which one is positive, and then through logic, through like, well, if this one's positive, then the other ones aren't positive, you know what the other ones are. So this T means that tangent is positive. Since tangent is positive, sine and cosine are both negative. So if you're looking at that unit circle again, you'll see that the both ordered pairs in that third quadrant down here, they're both negative. We're going to get to answering some of those questions, but this is what's needed to kind of understand that. C refers to cosine being positive, and since cosine is positive, sine and tangent are negative.
Okay.
Is there any questions on this, kind of what goes into this to understand this?
No, makes sense.
Okay. Now we have to use it. We have to do something with it. So what I'm gonna do here is I'm gonna make a few of these up. Okay, so again, we've got this. All students take calculus, and I'm gonna say, okay, where is sine positive, and where is tangent negative? Okay, so where is sine positive? Well, they're all positive here, right?
Mm-hmm.
So that's good. Where is sine also positive? Which other quadrant is sine positive?
The second, yeah.
Second one. Remember, it goes 1, 2, 3, 4 counterclockwise. Don't know why, but that's the way it is. Tangent, where is it negative? Well, it's positive here, and it's positive here. So it must be here and here.
Mm-hmm.
Now it's these two because sine is positive, so the other two are negative. Cosine is positive there. This overlaps in quadrant 2. What is the angle measure from here, from sort of this place to this place? Do you remember that from the unit circle?
What is the, wait, can you say, oh.
Like this is 0 degrees, this is 270 degrees. What's the angle measure here and here?
180, and then,
oops. This is 90 and this is 180.
Yeah.
And really we want you to be doing it in radian there. Okay.
And isn't the 0 also 360?
It is, because it comes back around. Okay, let's do another one here. So again, ASTC. Where is cosine negative and tangent positive?
So cosine negative in the second quadrant.
Agreed. Where else?
And in the third quadrant.
Okay.
And then tangent is positive in the second and the first quadrant. Yeah.
So the second quadrant, tangent is negative because only sine is positive.
Oh.
This is sine positive, and that means that cosine and tangent are negative.
Oh, so in the first and the third.
That's right. So see how the overlap is there?
Great. Okay. So then for that, like, what would you write as your answer? Like
quadrant 3. We're just talking about quadrants and then the angles. So like I would want you to know this is pi to 3 pi over 2. But it's really quadrant 3 is your answer.
Okay.
Okay, so now we're going to talk about, this is very much related. I appreciate you allow me not to stick to just what's on here, because it allows you to actually learn a few more things. If I tell you that sine of an angle is minus 5 over 13, what is the cosecant of that angle?
13 over 5, negative 13 over 5.
Do you notice that they're both negative?
Yes.
Okay. We're going to do the same thing here. Let's say I tell you that the cosine of an angle is minus 4/5. What is the secant of that angle?
Negative 5/4.
Okay, so these same thing here. These have the same thing. So what you have to realize is that this thing that I just said about ASTC, all students take calculus. If I tell you that sine is greater than 0, that means that cosecant is also greater than 0. Like these are essentially the same.
Oh.
And if I tell you that cosine is greater than 0, that means that secant is greater than 0. And similarly, like if I tell you sine is less than 0, then cosecant is also less than 0. So what I'm trying to get you to see is that there's really only two trigonometric functions, sine and cosine. These other ones are like variations on it.
Mhm.
Okay, so we're gonna try a really straightforward one. This is not meant to be over the top, anything difficult like that. So let's say I tell you that secant is positive and cosecant is positive. If I tell you secant, I'm really saying cosine. Where is cosine positive here?
First and fourth.
Okay. Cosecant, I'm really saying sine. Where is sine positive?
First and second.
First and second. So the overlap is in the first, obviously.
Uh-huh.
Okay. So let's do it with a little bit more challenge here. ASTC. Let's say that tangent is positive, but cosecant is negative.
The tangent is in the third and the first, and then cosecant is
Which is really which trig function?
sine.
Sine.
So first and second.
So sine is positive in the first and second. This one is.
Oh, it's negative. So third and fourth.
And fourth. Okay, so let's try another one here. Where is let me draw this again. Where is cosecant positive and secant negative?
So cosecant positive in the first and the second, and then first and fourth.
So this is really cosine, right?
Yeah.
Cosine, it's negative again.
Negative. I can't do that. So third and third and second. Was I right?
Yes.
Okay.
Yes. Okay, so this has to be like, you have to get that really clear in being able to do this, because there's some questions that are asked based on that understanding. Okay, so now let's talk about where certain things are undefined. So tangent of theta equals sine theta over cosine theta. This is undefined when the bottom equals 0. Do you know what a graph of cosine looks like?
It starts at up and then it goes down. And
looks something like that, right? So where are these two spots? So I'm writing them, but do you see on your unit circle there, do you see the, what is the x value at pi over 2?
Pi over 2, x value is 0. No.
Okay, and how about at 3 pi over 2? What's the x value?
0.
It's also 0, right?
Yeah.
But this continues on, so it's not as if like those are the only two places. It actually goes on, forever, right? So this continues. Like you keep going around the unit circle and get there. How about cotangent? Cotangent is 1 over tangent. That's not super useful. It's also reciprocal of this, so it's cosine theta over sine theta.
With that first graph, that's the graph of sine, right?
This is cosine up here.
Oh, cosine, okay.
Because we're trying to figure out where does it equal 0.
Okay.
So now we got to figure out where does sine theta equal 0? We got to look at a graph of sine. So sine
That's the one that starts at the origin, right?
starts low, goes high, comes back down, and then back up. So that's 2 pi, that's pi, and so on. Okay, so the problematic areas here are pi and 2 pi. But again, this goes on forever. So there's another one there, and then it comes back up, and so on and so on and so on.
Mm-hmm.
Okay, so give this, and again, because these are the same. Since these are the same, if I say where is cosecant of theta undefined, and I say, well, on 0 to 2 pi, cosecant is really which trig function?
Sine.
1 over sine. So I'm just really asking you, where does sine theta equal 0? We already answered that up here.
So would you put like pi and 2 pi, or would you put like
Actually put 0. 2 pi is not includes a 0 and pi.
Oh, wait, why?
That means it's not included.
Oh, okay.
Okay. All right. So we got some more conceptual stuff, I guess. I'm going to move to 4.4, if that's okay.
Yeah. I have a lot in here, I know.
It's all what you presented to me is not consistent with what I see in other students taking this class. They have a lot more tactical problems where you actually just, you kind of do it, recipe, do this. These are like sort of like the questions you would get at the end after you've done them all to see if you.
I like more like recipe problems.
Yeah. Okay, so let's suppose a function has a period of 4. So there's a lot of those, but let's just look at a sine graph that has a period of 4. So I'm gonna do that for you. So sine 1/2 pi x. Okay, now why does this have a period equal to 4? We're going to talk about that. So this right here is called b. You've probably seen that before, b. And the period of a sine or cosine is 2 pi over b. So it's 2 pi over 1/2 pi. And if you think real hard, you'll see that that reduces to 4. Okay, well, what does that mean? It means that from where you start, and where does sine start again?
At the origin.
The origin, it starts there. You got 1, 2, 3, 4. You got one period. And then you got half a period. So that's 4, that's 2. It goes up, and then it comes down like that.
Mm-hmm.
Okay, so now, does this have a maximum value at 3?
No.
Looks like it has a maximum value at 1. But could it have a maximum value at 3?
Oh.
What if the graph looked like this? Does that also have a period of 4?
Yeah.
It does. So what's the difference between the solid line and the dashed line in terms of like this right here? Because the period's the same. It has to do with out here in front. What is that?
Negative.
Be negative. Okay.
But the maximum would still be 1, right? Or negative.
Well, if it goes like this, the maximum is actually at 3. What I'm trying to show you is that like we can answer these questions like that's great, but like, do you understand that the maximum either occurs here or it occurs here, depending on whether it goes this way or the other way?
Yeah, but it goes up to the same height, so how would they have different maximums?
Oh, okay. This is me asked what this is right here. It says where, and the question you're asking is the what. So it's like has a maximum value what you're missing here is the of y equals 1 at x equals 3.
Oh,
This is the what is it? It's like, where do you live? I live on a street. Okay, and what do you live in? I live in a house.
okay.
And they're different questions, but we sometimes get them to overlap there for us.
So it would be the answer is yes, right? Or true.
No. The problem is that at minus, we need to draw we need to draw more of this, okay?
Okay.
Because what I gave you is like one possible thing. I also started mine at the origin. They want to do it at 3 and 1.
Okay.
So like is it possible to have a maximum value at -1? So let's try drawing that. So here's the max, okay, at -1. And we know that one full period gets us here. So we got to return back to that place right there. So is it possible that the graph does this?
Yeah.
Like, yeah, that's reasonable. Now, does it have this behavior? Does it have a max at -1 and a max at 3?
Yeah.
Yes. So that is possible.
Okay.
Now, is it always true? You know, I don't really know how the instructor's asking this, but that's why these are kind of challenging questions, because they
So
require a
it's
lot of.
false or it is true?
No, it is true. It is true, but um, it could be false. Like it could be. Well, no. I guess it does. It does say that it has to have a maximum at these 2 points. Yeah,
So it's true.
it
Okay.
is true. What it's saying is that if you go one period, you get back to the same point. What I was thinking about, and I think this is relevant, is to drop is, let's say it was a minimum here. Like it could go up and be a minimum. If this is a min, then this has to be a min.
Okay, so if it says like max min or if it says min max, that would
Yeah.
be false.
Yes.
Okay.
Okay. Okay. So let's go to one of these graphs down here, because I think this will be very helpful to look at. I really don't like these graphs, but this is what we have.
I don't know why it has these little like black boxes.
Yeah, they're meant to represent one unit. So I'll go through 4. This is some overlap, but this is like a necessary. It's like this is a very basic, not basic. This is a very like fundamental thing that you have to know. The box is meant to represent one unit in each direction.
Is that the same thing for the circles on the 4.3 one? Because it had not the circles, but on the circles they had the black dots, the black squares too.
Is there those are no, those are like, I have no idea.
I don't know what those are.
I think they're meant to. Initially I was thinking they were there to like cover up, but
Sure. Okay.
but let's just see what we can go through in this, because there's a lot here. And this one's tough because you may not know right away what this is. And if I draw a cosine starts high, comes low, comes back up. That's a cosine.
Right.
A negative cosine, though, starts low, comes high, and then comes back down. That's a negative cosine. Do you see that this is a negative cosine?
Yeah.
Okay, great. So you always start with the one that's like clearer to you, and because you have to do them both in this.
Wait. No, how isn't that a positive cosine because it's going like? Oh, but it's in the middle. Okay, never mind. No, I get it.
Okay, so this is a negative cosine. Negative cosine. We know that. There's 4 things we have to find: A, B, C, and D. The order we find them in is generally 1, 2, 3, and 4. B comes from the period. So the period equals 2 pi over B. And if you rearrange this, you'll see that B is equal to 2 pi over the period. So you need to know the period. The period is two things. It's peak to peak. Well, it's many things. You can go peak to peak, or you can go valley to peak and double it. And we don't have it here, but you could also go valley to valley.
Okay.
Or you could go like, where does it start to where does it come back to where it starts? Lots and lots of options. You pick the one that you like here. In this case, your period is right minus left.
Okay,
So 2 pi minus a minus 2 pi, which is 4 pi.
Okay. So it'd be 2 pi over 4 pi.
Yes. So it's 2 pi over 4 pi, which is 1/2. Okay, and so B is 1/2. Great. C is the phase shift. Okay. Now the fact that this is flipped is not a phase shift up here. A phase shift is like, does it move left or right? And it does not move left or right. Okay, so in this case, C is equal to 0.
Okay.
A is not the amplitude. It looks like it, but it's not. The absolute value of A is the amplitude. Okay, the amplitude is the max minus the min over 2. And that's where these boxes come in. So the max is like 2, the min is minus 2. So it's 2 minus a minus 2 over 2, which equals 2. Lots of 2's. That's your amplitude. But that's not A. We already know that A is negative because it starts down. So A is negative 2.
Okay.
Okay, D is the vertical shift. So the vertical shift D, it's very much related to A. It's the max plus the min divided by 2. So in this case, it's 2 plus negative 2 over 2, which equals 0. This is also referred to as the center line. So do you agree? Do you see here that the kind of like what cuts right through the center line is 0?
Yeah.
Okay. So we've got this formula A cosine bx plus c plus d, and this becomes negative 2 cosine 1/2 x, because c and d are 0.
Okay.
Is that okay?
Yeah.
All right. So now the next part is much harder. We have to convert. We have to do a sine graph of this.
To find the f of x and g of x, is that right?
So this is where it's a little bit harder, because you're like, wait, doesn't sine usually start like there? It's like, yeah, it does. So we need this point. Well, we need this point right there. And I have I guess it's 2. I guess it starts 2 units over.
Okay.
I don't know. What do you think? Does it?
I mean,
I guess so. We have to do the same thing, and some of it's very much related. So it's A sine bx plus c plus d. So here's what's true. B is still 1/2. Okay. A is still, well, we can't talk about A. D is still 0, but A and B are I'm sorry, A and C are what are different here.
okay.
Okay. Now, this is the tricky part here. This is like the part that's like, so do you see how if we believe that, not believe, if we see that we think that it starts here, this goes up. So A is now positive, not negative, because it's not like it's going down to start. It's a sine wave. Like if you can imagine this whole thing shifted over, it starts at the origin, goes up. So A is positive.
Okay.
So A is positive 2 this time. C we just mentioned is well, what we mentioned here is that the phase shift PS is 2. That's related to C. Okay,
Wait,
and this
what's PS?
phase shift.
Oh, okay. Okay.
So the problem though is that what really needs to happen here, and I don't even know if you've seen this before, is it's a sine, and you're supposed to pull this b out. So it's x plus c over b is what goes here, plus d, and c over b is what is equal to, because it's going right. This is supposed to, it ends up being -2 because it's really 2 right, not.
That's okay.
Okay, so this is the, I mean, maybe you haven't seen this before, but
Yeah.
we do know that b is a half, so it's c over 1/2 equals -2. Okay, so then your c here is equal to, multiply both sides by 1/2 is -1. Okay, so now we can go back, a sine bx plus c plus d, and we can go 2 sine 1/2 x minus 1, and that's our other one.
Okay, so is f of x the first one that we got, and then g of x is the 2 sine 1/2 x minus 1.
Yeah, so according to the instructions here, f is the sine, so this is your f of x, and
Oh,
and the other one was your g of x.
okay.
What we just did is a very advanced thing to do. It's to be able to write it 2 ways. It's very sophisticated because you can't, usually one way is very clear and the other way it's like, what do we do?
Yeah. Interesting. Okay, we've never done this in class, so
Yeah.
wow.
So looking ahead in your like 4.5, we kind of covered some stuff here. 4.6 covers sort of like a sum and difference of these trigonometric functions. A lot of this is done with graphing, so I would probably ask your instructor if you're going to have access to Desmos or a calculator, what they expect you to do.
Okay.
Like I'm sort of seeing like a lot, like there's like a lot of you've covered a bunch of things, but not in a lot of depth. So then, like, what are they testing you on? Is it like, because to me, I'm seeing graphing problems. I'm seeing right angle trigonometry problems.
And she said that she might even throw in some function analysis because we did that last semester. I don't know. I'll ask her, and I'll probably schedule another lesson with you before the test because it's on Thursday. So, and I'll try to get as much done of this as I can before then.
Yeah, and as you like, I know for best helping you, we would need to do this a little bit slower and more concentrated on a couple of topics.
Yeah.
So I'd be happy to help again. Uh, just let me know maybe how to help you best for next time if we do another lesson on this. So
Yeah, I'll
I'll
have some specific stuff. I just haven't started doing
okay.
this packet yet.
So what I'll do is I'll send out the notes and the screen recording here shortly. Definitely, before too long, probably after 3 o'clock,
Okay.
and then be happy to help you again next time. So
All
thanks
right.
again for scheduling.
Thanks. Bye.
Have a great day. Bye now.